This very large, heavy, palletised delivery arrived at my little workshop, courtesy of Monport Laser. This is their 60-watt CO2 laser, and as you can see, it is very, very well packaged. It's in this very sturdy crate made of heavy duty plywood. You can see it's the MP460 there. Time to do some serious unboxing. I was very glad I had my impact driver. There were one heck of a lot of screws to take out. I started by removing the lid. Very well packaged with foam. Removing this reveals this lovely machine. I really like the colour of it, and I like the industrial look of it. Now to remove the sides. These coach screws. There are these metal brackets on every corner. Once again, very glad I had my impact driver. Just take your time unpackaging these, you don't want to damage anything inside. Removing the front, you can see there the Monport logo. It really is a nice looking machine. Once all the sides are removed, you can get a better look at it. It's covered in shrink wrap or saran type wrap. I really like the look of this, but it is huge. It comes screwed to a pallet. That pallet was fixed to another pallet. The 4 adjustable feet on the laser were screwed to the pallet with some very long screws. I'd built this mobile workbench ready for the laser. Originally I was going to be sent a desktop version. This one is somewhat bigger, so I used one of the sides off the crate to make the top of it a little bit bigger. Got my mate Gary next door to help me lift it on there, and it took 2 of us and a lot of effort to get it on there. It's very, very heavy. It's all metal construction. You can see the fume extraction fan there spinning in the wind. Honeycomb bed, that's the air assist pump. That's the water inlet and outlet for the cooling. And everything is oversized and heavy duty, which I really, really like. Great big stepper motors, brilliant cable management, proper industrial controls, the usual warning labels of course, and everything was well fixed so it didn't shift in transit. So I had these ties to remove, and there's a set of keys there attached to the laser head, and all the mirrors were covered with these little cloth bags as well to keep them safe. Really, really well packaged, and nothing had broken or shifted during shipping. There's the keys. One of the keys is for undoing these panels, and undoing the front panel, you can see underneath there's some more goodies. They're all underneath the bed. Firstly was this tool bag with some laser goggles and various leads, tools, double-sided tape. That's an Ethernet cable if you want to connect it to your network. USB cable and a memory stick. Also a good set of instructions. Generally these were very good and very clear, although there were a couple of bits omitted that applied to this laser, a couple of extra controls that have obviously been added. And this is the mains cable, and yes, it's a UK one. This shipped from Monport's UK warehouse. Underneath the honeycomb bed are these there's a grid system, a sort of a rack you can use. That's the fume extraction hose and tubing for the water cooler. Just removing these this racking at the minute so I can get to this other box. And then this is a water pump. This is to keep the laser tube cool. We undo the back. There's the laser tube itself and another mirror with a cover on it. So there's a bit of packing tape to take off this. There it is in my workshop. I can no longer get in the workshop, so I ended up having to shift a lot of stuff around so that I could fit it in there. It went in the end, it just hasn't left a lot of room. Next, to do the water cooling system, so I've got a bucket, a lidded bucket here. This is a bait bucket, just upcycling, and some deionised water, 10 litres of it. This is just some protective tubing to keep any water that there was already in the system in there, because they test them, so there might be a bit of water in there. And I'm putting the 10 litres of distilled water into the bucket. But all very simple. And there's the hose for the fume extraction, big Jubilee clip and silicone hosing for the water cooling. You can also see an earth lead there. Don't need this in the UK because we have earth 3-pin sockets, but otherwise you would need to connect this earth to something. Just adapting the bucket lid on my drill press. So we've got an in and an out for the hosing. I had to cut a slot between these two to fit the plug through. So there we are, tubes threaded through, plug threaded through, and this is a submersible pump. It's an aquarium pump. I used the Venturi attachment to cobble together an attachment for the hose so it all fitted. Drop that into the water. The bubbles are just air being expelled from the pump. Can then put the lid on to keep all the dust out of the water. And I've installed it underneath the laser. The pump plugs into the pump plug on the back. It's automatically controlled. Just tightening up that fume hose on the back. You can see the connections for the water. This is the mains plug. That's our UK 3-pin earthed 13 amp fused plug. That goes into a standard wall socket. That is the master switch, the main electrical switch on the back. It makes quite a cool sound when this starts up. The air assist pump and the water pump are going, and the fume extraction fan is going. It's all working very nicely. Just coming round to the front. Control panels lit up. I'll try the emergency stop in a moment. This is when it was first switched on. I didn't really know how all the controls worked. Just turning it off and back on again. At the back there you can see the big lead screws. You've got one on each corner of the bed, because on these sort of lasers it's the bed that moves up and down to achieve focus, not the laser head. So here we are at the back of the Monport CO2 laser. We've got this heavy cover here, and under this is the tube that generates the laser beam. It's a water cooled tube. You've got the associated pipework there. The beam is generated within the tube. It's fired out of the end and it hits that angled mirror there. You can see there's adjustment screws on that mirror to get the angles right. When you first get the laser, you need to just check that the alignment of these hasn't shifted. You do that by putting painter's tape on and test firing the laser, making sure it hits centrally on that little circular bit there. Luckily mine were all well aligned and hadn't shifted, because it can take quite a time fiddling about with the mirrors to get them all aligned. But that first mirror bounces the beam through that dark hole there to a second mirror within the laser bed housing. So we're inside the laser here. There's that hole at the back where the beam comes through off the first mirror from the tube. It then hits this second mirror on the gantry that slides up and down. As this moves backwards and forwards, the mirror should stay in alignment. Important maintenance is to make sure these mirrors are kept clean and check the alignment if anything changes. Moving along to the laser itself, and there's a third mirror here which directs the beam down through a focusing lens and onto your workpiece. This bit here is a little light, a little laser light which shows where the laser beam is going to hit, helps you align things. And this black tube here comes from the air assist, which is all built in. The air assist fires a jet of air down the path of the laser beam, which helps clear smoke and soot out of the way to make a more efficient cut. So 3 mirrors and a focusing lens, all of which need to be kept clean. I'll give you a quick rundown of the controls here, because it's not very clear on the instructions. I think this is a sort of a newer version that's on the instructions. This is your emergency stop switch, which I use it to actually turn the laser on. It's all plugged in over there. This is the switch for the LED lights inside the bay, so you can see what you're doing. This is your main control panel, which gives you a lot of independent controls without having to use your laptop. This is the block used for focusing. This is the key for undoing the panels. Now here we've got 3 lights. This one shows it's switched on. This one shows the laser is armed and ready, so to speak. The green shows that the laser's working. To get this to light up, you'll need to turn this on, you'll need to turn that on, and you'll need to press that, which took me a little while to suss out. And you can't actually transfer the files for burning from your laptop until this orange light is illuminated. Let's turn it on. So So you can see there's lights in there which you can turn on and off using that switch. And then to arm the laser, it's that, and there you go, amber light lights up. You can then pass the files across and start your burn. This is LightBurn software. This is one of my favourite bits of software. I use this for designing my laser projects and controlling the laser. And luckily this Monport laser is controlled by LightBurn. You can see I've selected the laser, linked it to LightBurn. You will need the PSD version of LightBurn. Then we've got to focus it, so we've got the menu set to the Z movement, and there's the up and down there, which is actually the left and right arrows. Using the supplied spacer to get the focus height right. You can see the little laser dot just to check your positioning. Yep, wear your safety glasses. So we're ready to go. Laptop's all connected. You can see on the display there all the different settings they've come up. And then we hit start. And away it goes. It cuts this laser ply absolutely beautifully. These are different speeds I'm trying out here. I sped this bit up a little bit, it's a bit tedious. But this is a test cut just to see the optimum speed for cutting the plywood before I take on a more serious project. It's worth doing a few of these test burns. There's another test cut. Here I'm testing engraving. So different speeds and powers just to see which gives the best result for your project. For some of my projects I need a certain depth cut. And so this is not only testing how dark it's going to produce an engraving, but how deep it will engrave as well. As I say, well worth taking your time to do a few test engraves. I'm not always very good at testing small things. I often go ploughing straight into the project and realise I've got my settings wrong. So it is well worth doing these. And that's quite graphic, the result there. This is 3mm laser ply. This was one of my first, I think this was the first proper project I did on the laser. This is to create a pistol grip for a target rifle, an air rifle target rifle. So this engraving part here is actually to cut a recess in the plywood, and we're then cutting out the outline. So different settings for the engraving part and the cutting part. Really fine kerf on this laser, kerf being the width of cut. You sometimes find with diode lasers that as you increase the power of a diode laser, the kerf often increases as well. With a CO2 laser that's well aligned and focused, you're getting lots of power but still maintaining a fine kerf. So this is a basic profile, part of this hand grip, pistol grip I'm making for a rifle, and you can see the edges, how clean they are. They're not black and sooty at all. You can see the two different settings are actually on the laser display. Here are the other components, the different layers, because I'm building up what you would call a blank, a carving blank, which I'm going to custom carve to make it a perfect fit to the hand. So there it is, cutting all the outlines. Just move these tools out of the way so you can see the green lights on, showing that it's working. And it's got a visual display, although I haven't focused this very well, showing the progress of the laser. And there are all the parts cut out and in order. The little circles I've cut out around the side are to help align the parts. Anyone who's laminated wood will know when you glue it and clamp it, they have a tendency to slide. So putting these bolts through the holes keeps it all lined up while you glue it. Well, there it is, all glued up. So it's got the actual precision bit that fits what's known as an AR-15 style pistol grip. I've now drilled through, joining up the holes for the bolt attachment, and I've cut off those eyes around the side. And there's the finished pistol grip, all carved and dyed, stained. But that's a perfect fit for my hand. That's quite a satisfying project. I then thought we'd test some acrylic perspex type stuff and some leather. So I've done a couple of designs here. Don't forget to refocus when you change material. This is some 3.5mm vegetable tan leather. Just doing a framing movement here to make sure that my design fits this offcut of leather. So we need to arm the laser. Goes to amber. And then we hit play. The one problem with leather is it creates horrible stinky smoke. You can see a little bit of smoke stain on the surface of the leather. This just wipes off with a damp cloth. So although it looks terrible, it's very easy to wipe off with a damp cloth. I did several experimental burns just to get the right settings. I found you had to use very low settings for engraving the leather, otherwise it burned too deeply. So low power, high speed. I think this was one of the first ones, and I reduced the power quite a lot for subsequent ones. And it's doing the cut. This is for a key fob for the local gun shop. And that's it, all done. Didn't take long. That was actual time. And there's the finished key fobs, all cleaned up. Bit of leather dye on them and some Resolene, Phoebing's dye and Phoebing's Resolene, just to seal them. And they've come out very nicely. Very pleased with those. I'm sure the lads at Brothers in Arms will be too. Now to some 3mm clear acrylic. I really should have started small. I did a full-size coaster straight off and I'd got my settings a little bit wrong. The engraving's a bit deep. That dustiness wipes off, that's not a problem, but I hadn't quite cut through. So I needed to slow up the cut and lessen the power on the engraving. I did a couple of smaller ones then and they came out very well. I still need to experiment a little bit. I then thought I'd better do my usual laser test burn, which is how I test out all the lasers. This is a very good test of laser accuracy because it's all got to slot together. If there's any inaccuracies, it won't. It assesses how wide the kerf is and how square everything is cut. But this is actual speed, so you can see it's very quick for cutting this laser ply. You can see the progress there on the screen. You can actually see what the laser is doing. As I say, this is a good sort of benchmark really for a laser. I do a lot of box cutting with the laser, with my lasers, so it's important that this aspect is good. There's the design in LightBurn. Here it is, just coming to the end. You can see it's cutting through because the smoke is coming from underneath the plywood. Coming through. The fact the little dots staying in shows the kerf is very tight. And there's the finished dice or die, and it is the best one I've ever produced from a laser. It is about as perfect as you can get. I needed a hammer to get it together because the joints were very, very tight, showing it's a very narrow kerf. And the finish on the edges is superb. All perfectly square, so it slots together nicely. Hello folks, back out in my workshop with the enormous Monport 60 watt CO2 laser. This is a big, heavy industrial type machine. Really nice build quality, rock solid, all metal construction. Many thanks to Monport for sending this to me to review. I hadn't quite anticipated how big it was going to be. I should have researched it a bit more. I used to have a workshop. Now I've got a big laser in my workshop, so I'm having to walk around sideways even more. But it is such a good bit of kit. Took a little while to suss it all out. The controls took a little bit of working out. How to arm the laser particularly and transfer files across took a little bit of working out because it's got several safety features. Also took me a while to work out why it wasn't autofocusing, and that's because this isn't the autofocus model. You manually focus it, but you use the control panel to manually focus it. You've got electronic switches for moving the Z-axis up and down, and you use the little block for your focus height. I'm still learning how to use this CO2 laser. It's very different in many ways to the diode lasers that I've used before. It cuts differently, different settings. I need to experiment with engraving settings. The cutting settings are a bit more straightforward. Engraving seems to need very low power, very high speed. Cutting, I'm still not sure about cutting acrylic, whether to do several passes or one slow speed pass to achieve the best finish on the edges of the acrylic. But I need to do a bit more experimentation on that. The cooling system, although it might seem a little primitive, a bucket of distilled water and a pump, it works. And for my usage, it's probably quite adequate. I'm not running this at high power for extended periods. The sort of usage this will get with me is sort of short bursts of work, and so the cooling system is perfectly adequate to keep the laser tube cool. If you are going to be doing higher volume, high power work, then I would recommend getting the Monport chiller, which is a plug-in separate unit that chills the cooling water as a separate sort of cooling system, so it'll keep the laser tube running cooler. This CO2 laser is very good value for money. I'll put some links in the description for you. For what you get for your money, I think it's very, very good. Cuts, as I say, does cut differently to diode lasers. It cuts the laser ply very, very nicely. There's a lot less charring on the laser ply. It seems to produce an almost clean edge to it. I'm not sure how. Leather, still a blackened edge. It will cut things that diode lasers won't cut as well, like clear acrylic. And I frequently need clear acrylic pieces for projects I do, so it's very, very useful. Really good that it works with LightBurn. I'm very happy about that because I love using LightBurn. It's a very capable bit of software, something I use a lot. So it's really nice to have it LightBurn compatible. You will need, I think it's called a PSD version of LightBurn. It won't work with the version you've probably been using with a diode laser. You will need to upgrade your LightBurn software. It's got lots of safety features. Hopefully I've inserted a small clip showing the controls, and there's 3 different switches on the top of this for arming the laser. So it'd be very difficult to accidentally arm the laser. As I said, thanks to Monport for sending this to me, and I shall be back soon with some more videos. Many thanks for watching. Please like, share and subscribe, and check out the links in the video description. There will be a discount code there for the Monport laser.